here. I'm recording my final solo project video for CMP428 video game programming. I'm going to start with some code that I got from the book first. So I did do some work to it to make it work for me, but it is mostly from the book. So first it's going to be my input manager. So that's going to be this input manager, which is, it basically implements key listener, mouse, motion listener, mouse wheel. I didn't use any of that besides the key listener. So basically what it does is it just opens up a key listener when you construct it, and then it uses this thing called a game action, which is another class. But besides that, that's really all it does. The game action class does all the work. And the game action class, it has states like normal and detect initial press only, which make it really easy to use. So when you construct it, you pass in a string name, and you could also pass in a behavior. This behavior is the state. So like if you want something to be detected, like movement, where you want it to be detected continuously, you would leave it as normal. But if you want it to be detected only once, like maybe like a fire button, like a shoot button, you could set it to detect initial press only, and then you would have to continuously press it. And then you basically set that up, and you'll see how it's set up in the game. And then you check is pressed, and that returns a Boolean that tells you if it's pressed or not, and then you could do an if statement or something like that to get it to do something. That's how that works. Animation BK is animation from the book. It's very similar to the animation that we worked with in class. The only difference is that it has an array list of anim frames, which is an object. It's an inner class right here. The only reason they make this is because it has an end time. It's just an image, but it has an end time. An end time is how long the image is shown. So the difference here is that it's an array list of images, and you could choose how long each one is shown. So when you construct it, you can just pass in an array list of anim frames. You can add a frame where you just pass in an image and a duration, and it just constructs a new anim frame right there while adding the frame. And the update works the same exact way. Very similar. It just goes through and updates it, and you can get the image right here. And then I used it the same way that we use our animation in class. I also used camera, which we used in class. Just static camera, very easy to use. It was very useful because I had motion and my screen moved. And I also used Rect, but I did add some stuff. I added a lot onto Rect, but that was mostly in my class. So there is the velocity. And then bounce off vertical and horizontal surface. But all the add-ons is the Lunar Lander class. It extends Rect. This is the player's avatar in the game. It has acceleration variables that keep track of the acceleration. The speed and gravity variables do not do anything. This was when I tried to convert the game to a JPanel, which I did not finish, so those are unused at the time. These animation images are used. This is the Lander's actual animation. It has a flame animation. It has a crash animation, which is set. I just haven't set it to play when the lander dies. So I can set it when health equals 0, so that shouldn't be too much work. I might actually do that. It has a weight and a fuel, which work in conjunction. Weight works so that when you are flying and your acceleration is used to create a space-like environment for your space-like motion for your lunar lander. As your lander gets lighter and your lander gets lighter as you use more fuel, your lander gets more reactive. So you burn fuel, you get more reactive, and you can pick up more fuel, but then you get heavier and you get pulled down more easily. So it's a delicate balance, and you have to decide whether you want to pick fuel up. Bullets are your ammunition. Health is your health. Projectile array list. It's just an array list that holds all the projectiles that you have shot. You have a constructor, which just passes X, Y, with an height into super, and then everything else into everything else. Update is also part of the J panel stuff that never got finished. Get weight returns weight. Get current weight. This I just have to fix because fuel over 1.0 is just fuel, so I just have to fix that. But it was just because I was in an infinite loop. This was from a while ago though. Get fuel just returns fuel. Add fuel is when you get a pickup, so it just adds fuel in to the current fuel. Get ammo returns the bullets. When you get an ammo pickup, it just puts in ammo. Returns the health. When you get a health pickup, it just puts in health as long as it's not over the maximum health. When you shoot a projectile, it adds a projectile to the projectile array list. It constructs the new projectile right here at the location of your lander, this.x, this.width divided by 2. So it adds it so it's a little bit in front of your lander, so it doesn't look like it's coming out of the middle of your lander. And this.y, it's a 5x5 rect, and it subtracts 1 from your bullet amount. You can get this array list, and you can remove any projectile from that projectile array list. Burn fuel. So anytime you maneuver by pressing any input, you will burn this much fuel. I was burning 1/60th of a second, which gave you 100 seconds of flight maneuvering time, which was way too much. So I made it burn fuel much faster. So you had much less decision time. You had to think much faster, and you had to do things faster. Lift just gets you lift. Setting acceleration and move based on physics are used to move based on acceleration. Move based on physics actually it bars the acceleration. It what's it called? It makes sure the acceleration can't go past a certain amount, because if you accelerate infinitely, you will shoot right off the screen and you'll never be able to control the craft. So it limits it in both directions. Move left and move right are just the normal move left and move right. Lift, excel, move left, excel, move right, excel, gravity, acceleration, side deceleration. These are all just used to mimic the motion of outer space. You could set the flame animation and crash animation here, and this just draws it. So we have our enemy right here. This is an abstract enemy class that all the enemies take in. This also extends rect. It's very similar to the Lunar Lander, except it doesn't have the spacey feel, spacey motion. So you have the enemy animation, the flame animation, which isn't used because the enemy animations already have flames on them, and the crash, which also isn't set yet. This also has a time for it, and that's so I could delete it after a certain amount of time. So it's not just being, infinitely updated and using up processing power. Health is only for the boss, because everything else only has 1 health and is deleted instantly once it's hit. And it also has a target, so the enemy can either be stationary or fly up and down. These are all the different types of enemies that I imagined when I first started. Some of them came to fruition, some of them were just fantasy. So the constructor just passes some things into rect and just, constructs some things. It has 2 update functions, which is really only for stationary enemy. Everybody else just uses 1. You can return the health, you can return the age in seconds, and you have the draw function. Stationary enemy. So the stationary enemy just bobs up and down in place. It's just a simple obstacle. He has a sprite, which is static, so you don't have to, now that I think about it, I've tried to make, this is not static because there's only one of them, but I tried to make the actual the things that get instantiated static. So you'll see as I go, like the kamikaze enemy, the boss, those are all static animations, so they don't have to keep getting instantiated every time I make a new one. So its constructor, it just calls super. It takes in the target, which is the Lunar Lander, and health. The move up and move down, so these are the 2 updates, so it just goes up 4 pixels, down 4 pixels, up 4 pixels, down 4 pixels, and it draws. Kamikaze enemy, static animation, just passes everything into a super. Update is it just moves left across the screen, basically towards the player. It's your choice whether to avoid them or kill them, but they do become a problem if you do just ignore them and try to avoid them. And then the boss. So the boss is going to be a huge enemy that can take multiple shots and that blocks the end of the level. So the player can't win unless the player beats him. He will also shoot some projectiles and some kamikaze enemies. That's how the kamikaze enemy becomes a problem. So this boss has, he also extends enemy. He has an array list of projectiles. He has an array list of enemies. So those hold the projectiles, that holds the enemies. And he has a difficulty scaler. So the difficulty timer scaler just basically holds him back from attacking for a certain amount. So his constructor is just the same as the others, except the difficulty scaler gets put in. The update. So what happens is he doesn't attack until he's a certain age in seconds. So when it's when the level is difficulty 1, he waits 10 seconds. When it's 2, he waits 20. When it's 3, he waits 30. And then he starts launching kamikazes and shooting enemies. So that's pretty straightforward. Did I go over shoot in this? I did. But there's also a shoot in here. Same thing, except this one gets a random location because it puts it on a random Y location on the screen between 800 and 200. That's because this is maximum minus minimum plus minimum. So that's between 800 and 200, and just it starts at the X location and anywhere between 800 and 200 on the screen. So it'll just shoot random projectiles all across the screen. It also does the same thing with kamikazes. Random kamikazes all across the screen, just shoots a bunch of them. So that's the enemies. And then we also have UI. So next is UI. So this is actually, this is just a base class. I think it might end up being abstract at some point because I plan to keep working on this game. But what this was I tried to make a little hearts that represented the lander's health. And it didn't work because it had two different animations, and I was having trouble playing the right one, depending on how it was, because there's 2 health. So I had to draw 2 hearts, 2 full, or 1 full, 1 empty, or 2 empty. So what I did was I decided to just make this with an X and a Y location and the Lunar Lander passed in so I could get the lander's health. And then I made a UI empty, which had the empty heart static, and a UI full, which had the full heart. And I would just draw what I needed to draw. I instantiated 2, one UI full and one UI empty, and I just drew what I needed to draw based on the health of the lander. So now we have here the projectiles class, and this projectiles class is the projectiles that the Lunar Lander shoots. It extends rect as well. As you can see, it has an age that we create when we create it. It has a static animation, the projectile image. And when you instantiate it, it's called super, and then it sets its current time. So it has 2 functions, launch projectile and launch projectile left, L, left. So basically move right 30 or move left 30. Just move straight across the screen from where you shot it. You can also get the age in seconds. Now the reason it has both of these was because originally I tried to make this one class work for both enemies and the Lunar Lander, but I ran into some problems with that. Most importantly was that when I was shooting, after the boss started shooting at me, my projectiles turned into the enemy's projectiles. So how I solved that was I made an enemy projectile class. It's the same thing. The only difference is I made the static animation. The enemy projectile animation has all the same stuff, except it calls the move projectile left because he's shooting this way while I'm shooting this way. Yeah, so you get the age in seconds. Now, the reason I have get age in seconds for both these projectiles is that when you're flying around shooting a bunch of projectiles, there could be hundreds of projectiles on the screen. So they're clear off the screen after a second. So I figure I wait 1 second and then I delete them. If they haven't hit anything and they haven't and they're still there, they should go. They shouldn't take up any more processing power. So you'll see that implemented in the game. So that's projectiles and enemy projectiles. Next, we will do the items. So this is the abstract item class that also inherits rect. Pick up items like fuel and ammo that you can find scattered throughout the level. So what we have here is a strength. This is how much of its resource it restores, and you have the animation that is used. So the constructor just calls super and it sets the strength. You can get the strength. The abstract function is the pickup function. This is what the item will do when it's picked up by the lander. And it also takes in the lander for this function. And then you get the draw function. Okay, so we have the actual classes that are derived from them. So ammo, which extends items. So we have our static animation because this is actually going to be instantiated. So we made it static. So we only have one of these. Like I said, we tried to make those static as much as possible when we had an actual instantiated class with an animation. We called super for the constructor. For pickup, we had add ammo from Lander, which literally just says plus equals to the ammo. Remember, it just had this dot bullets plus equals ammo in for the Lander. So we just called add ammo, and we did the get strength, and that just adds whatever the strength of the pickup is, which we can set on instantiation. And we just draw the sprite. When we were drawing it as a rect, we just had the rect, and I was drawing an A in the rect, so I knew what it was. Fuel. So fuel is a class that extends item as well. This allows the player to fill up the lander with more fuel during the game. However, when the fuel fills up so suddenly, the lander will start to handle much less precisely. So it adds an extra layer of difficulty and strategy to the game should you take this fuel container or try to hold out for the next one. This actually worked out much better than I thought it would. Again, we have a static animation. This was one of the better features of the game. So we just called the super on the constructor. Same thing with the lander.add fuel, just plus equals the fuel. And it really does make it a lot tougher with the space motion of the lander. It makes it a lot tougher to fly when all of a sudden you get 50 fuel and you just drop like a rock. It's amazing what it does. And then health, same thing. A static health animation. This one we just have a check that if the lander health is less than 2, we add health. We do not let the lander health go above the maximum health, obviously. So that is all of the items. Now we have the actual level itself. This is the procedural generation that the level deals with. So the class is called ceiling. This is called that because I actually had a couple iterations of this. One was called level, one was called floor or something like that. But this one was the one that actually worked. It just happened to be called ceiling. So we have 2 array lists of rectangles, one called floor and one called ceiling. You can imagine that the floor one goes here and it has all the rectangles that go down here, and the ceiling one goes here and has all the rectangles that go in the ceiling. Then we have one rectangle, which represents the end platform. Then we have one static animation for the end platform. We have graphics device and display mode, which just represent the screen itself, the size of the screen. The X and the Y, location of the current grid on the X-axis, current grid on the Y-axis. Difficulty value, scalar value. So this is how you change the difficulty of the game. It can be anything between 1 and 3. So you have 3 difficulty levels, which scale up multiple different features of the game. You have height and width, which doesn't do... I'm not sure if height and width is actually used. Sectors X and sectors Y is used in the procedural generation. End dist is the platform, the end platform, how far out the end platform is. And this is the rest of the end platform information, the height and the width and the Y value of it. But the end dist is actually scaled with difficulty. The width of the rectangles on the floor and the ceiling, this is scaled based on the difficulty because the rectangles on the floor and the ceiling actually space out, and the floor and the level gets longer based on that. So you actually have to scale this based on the level. The offset, because with a Mac, when you use an applet, this has to be taken into account, and this is about 120 pixels. It takes up about 120 pixels. About that. So the variation is how far the maximum height of a rectangle on the ceiling or floor can be from the maximum, the maximum height and the minimum height of a rectangle on the floor or the ceiling can be. And this also scales with difficulty. So as it gets more difficult, the tunnel that you go through gets much narrower. And screen sectors is just used for the procedural generation. So in the init function, I get the local graphics environment, get the default screen device, get the display mode. Oh, so height and width is used for the mode get height and mode get width, and I take off the offset. So height and width are used. It's the height and width of the screen. So sectors X is the width of the screen times the difficulty divided by 16. So we scale it and then we divide it. And then sectors Y is the height divided by 3. So we have 1, 2, 3 rows and 16 columns. So that middle row is going to be our tunnel, the where the game takes place, and you'll see why in a second. So when we actually instantiate it, we take in an X and a Y. So we call in it, and then we have this random function. This random function just gives us a new random number based on the X and the Y. So we can get a new random level based on that. So we start a for loop, screen sectors.x, which is that point that we were working with earlier, that we instantiated earlier. So for screen sectors.x equals 0, screen sectors x is less than sectors x, screen sectors x plus plus. Then we instantiate two new random ints. One is the variation for the ceiling and one is the variation for the floor. So we have two different variations, so they're not the exact same things on the ceiling and the floor. And then we do two more for loops inside. So screen sectors.y equals 0, screen sectors y is less than 1, screen sectors y plus plus. Now you're probably asking why it's screen sectors y is less than 1 and not less than sectors y. And that's because the middle row, which is screen sectors.y or sectors x is 2, screen sectors.y equals 1. That's not going to be, there's going to be no rectangles there. That's going to be where the game takes place. And you'll see how this all makes sense in a second. So we add new rects for all of those. So this is basically going to add new rects into the ceiling array list. We just instantiate new rects procedurally. Screen sectors.x times sectors x, screen sectors.y times sectors y, width times difficulty, and a for the height, which is the random random height. And then we do screen sectors.y equals 2, screen sectors.y is less than 3, and then we add them to the floor this time. And then we have to do a little offset for the y value because they draw very neatly up top. Sorry, they draw very neatly up top. For the bottom, they draw on a straight line, and then they're uneven on the bottom. So we have to get them to draw on a straight line on the bottom and be uneven on top. So this is how we get them to be drawing straight line on the bottom. We do sectors y minus b plus sectors dot y times sectors y. That managed to work for us. And then end platform equals new rect. So we get a new end platform. We just scale the distance, the end distance by difficulty. And then we can draw all that with a simple for loop. And yeah, that's pretty much that. Next we have game testing itself. Okay, I'd like to show you my my actual level real quick before I play it. So this is the level tester. It doesn't implement key listener because that's done with the input manager. So we have the game actions and the input manager right here. We have graphics device and display mode for the size of the screen. Gravity, which is just for the landers, space mode, which is done over here in Game Test 3. Level Tester is just regular motion, which shows off just the rest of the game, and Game Test 3 is just for the space motion. So we have the lander, two separate UIs. So the UI full is the full hearts, and the UI empty are the empty hearts. We have the pickups, the ammo, fuel, and health pickups. Those each of those array lists hold a couple of each. No win equals true is how you know if you won or not. The ceiling, that holds the level. We instantiate it right there with 0, 0. The enemies array list holds the enemies. The bosses array list hold the bosses. Two bosses right there. We instantiate them right there. And we throw them in the bosses in the init method. We have two counters. Counter with the target 1 and the target 2, which slows down the update speeds. And a boss counter and a boss target, which slows down the boss attack speeds. And then we have a couple fonts that we use in the game. These image arrays are used for the animations. We instantiate the projectiles right here because it made it easier for them to be accessed. The init method, we get the local graphics environment and get the screen device and the display mode. We add some enemies, some stationary enemies, some kamikaze enemies, and the bosses, all to those array lists up there. We add ammo, we add fuel, and we add health, all to those array lists up there. We create the lander. We call the create sprites function down below, which I will show you right after the init method. We initialize the UI full and UI empties, which will just be will be two hearts right up here. The input manager. So move left, move right, move up, and move down. We just instantiate those as new game actions, and we pass in strings, which will be their indicators. Fire will be a new game action, but we called its state is detect initial press only. So you will have to keep pressing it to keep getting it. The reason I use this input manager is because for move up, move left, move right, move down, I got up, left, right, and down. You pass in those key events, but you can also pass in W, A, S, and D. Very simple. So it listens to both of those for those motions. And for fire, you just use space. And then we have everything normal except for the key listener. We pass in the input manager. Simple as that. Let's pass the run method real quick, and let's go down to create sprites. So we use the load image function in create sprites a lot. So it just returns toolkit.getDefault toolkit.getImage file name, which is the string file name that we pass in. We used it all the time in class. So these are all those image arrays. We actually instantiate them with the size of the animations that we have right here. So all these images are sets of images that make up animations. So we make the lengths here, and then we fill those images, those arrays up with those images right here. I try to make it as neat as possible. I mean, what can you do when you have so many of them? And then we actually instantiate the animations right here. And then we pass in the arrays one by one. We pass in the images. And so since it's the animation from the book, you have to pass in the ith image in the array and the amount of time you want it to run for. I just passed in 100 for everything except the heart array. I passed in 10,000 because those only have one image. So I just passed in 10,000 to make it easier for that. And then here, I just set everything. So the lander images, the projectiles were static. All these animations are static. All these are not static. So I just set them all real easy peasy. That gets called in the init method, and so it's nice and clean like that. And then we get into the run method. So we have the start time, which just gets us a time for our update for our animations, which is something we need. And we have a while no win, so that just tells us keep running while no win. We make sure we keep up with the elapsed time, and we pass it into some of the animations. We don't need to do it for all of them. Some of them just didn't need it for some reason. I never figured out why. Maybe something to do with the draw method. We have the input right here. So if move right dot is pressed, this is a function from the input manager, very simple. So we just have the regular motion here. We're not using the space motion that I have in game test 3, which is all I'm going to show you in game test 3 is the space motion. Everything else about the game I'm showing you here, like I said multiple times before. The projectiles are launched right here. So we call, we have a for loop where we get lander.getProjectiles.size, and because it adds projectiles to that array list, and then we just launch them. We call the launch method, which is a projectile method. So we have two updates because we're calling update 1 for everything here, like enemies.update, boss.update, boss projectiles.update, boss.enemies.update. And then we have here we have to check if it's an instance of a stationary update where we call update 2. And if it's a kamikaze update, kamikaze enemy, we just call update. And then same thing with boss enemies and boss projectiles, boss 2 enemies, boss 2 projectiles, we call the update method. And then we have the boss counter where we call the boss update. We just wanted to slow it. I just wanted to slow it down a bit. Enemy and projectile collision. This is just we go through the enemies.size, boss projectile size, boss.enemies.size, boss 2 projectiles, boss 2 enemies. If they hit me, you lose 1 health and you remove that enemy or you remove that projectile. If health equals 0, then you set no wind to false, and the game is over. Simple as that. Wall and platform collision. If you hit either the seal.ceiling, seal is the name of the class. So we set, where is it? Ceiling, seal equals new ceiling. So when we call seal.ceiling and seal.floor, we're getting the floor and the ceiling array list. So we're just going through the entire ceiling and the entire floor. If we hit either of those, it's game over. If we hit the end platform, it's also game over, except we win. Collectible collision. Ammo.size, that array list. Fuel.size, that array list. Health.size, that array list. If we hit any of those, we do the pickup, and then we do the remove. Simple as that. It stops rendering, it stops colliding. And then we do the enemy collide with player projectiles. So we check my projectiles, the lander projectiles, and then we go through the enemies. And if the projectiles hit the enemies, you remove the enemy. If the projectiles hit the bosses, you actually decrement the boss's health. If the boss's health is less than 1, then you remove. For the boss's enemies, they have to be accessed this way, because if you access them through the boss array list, after you kill that boss, its minions become invincible. So for the boss's enemies, you have to do boss.enemies and boss2.enemies. You can't do bosses.getI.enemies.getJ. You can't do that. You have to go to that specific boss, because even after boss is killed, you could still access his enemies. If you try and access this boss after you remove it from the boss's array, though, you cannot access these enemies. It will just make these invincible, but they could still kill you. Or I think, maybe not. I'm not sure, but I remember I couldn't touch them, and that bothered me enough to fix it. And then we have just the regular update method, and paint is just painting everything. We set the background color to a nice pink, and we set the color to black for the ceilings. We draw the lander, we draw the projectiles, we draw the pickups, we draw the enemies, the bosses, we draw some strings that give us our info, like the fuel and the health and the bullets. We draw our UI, we draw a string based on if we win or we lose, and now I will test the game for you real quick. So we have fuel right here, we have ammo right here, we have health right here. So fuel, ammo, health, stationary enemy, kamikaze enemy, and these are the ceiling and these are the floor. So that's me right there. I just shot him. Oh, I just shot him. I just picked that up. So as I pick them up, you can see my fuel and my ammo go up. So my ammo just went to 116, 166, but as I shoot it, it goes back down. But if I pick up health, it doesn't go up. So I still have 2 health. So I'm going to go hurt myself real quick. Bam. Okay, now I have 1 health. Let's go pick up that health. Bam, back to 2 health, 2 hearts. So all these things are coming from the bosses. So the bosses are launching all this stuff at me. This is a boss fight if you've ever seen one. So there's 2 bosses, and they launch tons of kamikaze enemies and tons of bullets at you, and you have to hit them 20 times to kill them on this level. So that's just on easy though. And there's no way I'm going to make it. Okay, so I managed to kill him. Well, yeah, I died. Okay, so I'm just going to slip by them this time. I think it's actually playing on a harder level, which I don't want it to. I wanted it to play on level 1. Yeah, it's on difficulty 2 right now. I want it to be on 1. So I wanted to show you the different difficulties. So difficulty 1, real quick. So you'll see that the ceiling is actually farther away. So if you keep an eye on my fuel, you'll see it just went up to 110. My ammo just went up to 70. Fuel went up to 120. Ammo went up to 120. Ammo went up to 170. You know, those things go up. I'm just going to slip by these guys. Hopefully I'll make it. Okay, look at that. And there's the end platform. It's animated as well when you land on that. There you go. You successfully landed and everyone lived. Okay, so as you saw, the let me just show you again. In easy mode, you can see that the edges are way far back, and the end of the game is actually at 250. So, 2500. So we're at 2500 right here. That's where the end platform is, and it takes 20 shots to kill the boss in difficulty 1. Difficulty 2, the walls start creeping in, and the end platform goes further back, and the bosses get harder to kill. So on difficulty 2, the walls, you'll see they're bigger and they're closer. So it actually takes much more. It takes 40 shots to kill a boss on level 2. There we go. That was 40 shots. And this time, the platform is all the way back at 5,000. And then we have the really hard level, the level 3, where the platform goes back all the way to 7,500. The walls come really far in, and it takes 60 shots to kill a boss. So the variation on the procedurally generated walls and floor and ceiling can make them very close. Almost, that's why you can't go to level 4. I mean, you could keep going level 4, level 5, but eventually, I mean, level 4 is pretty much unplayable. So, like, I'm just going to slip through right here. Like, they'll wait 30 seconds to start shooting because it takes a long time to get to the end here. So, 7,500. There you go. Okay, so that's the game. And let me go back to level 1 real quick. And this is the game's... the only different thing about this is that it uses the space movement. So this uses the weight and the move based on physics instead of the regular movement. So I'm just gonna demonstrate that for you, because when you put the game and the move based on physics together, it makes the game much more challenging, and that's the full game as it's supposed to be. So this is the full game. So you'll see the second it starts, I start dropping. So, and as I go, my fuel gets lower and it'll get much lighter. Yeah, see, I get much lighter and I get much more responsive. So it's hard to stop him the first time, but then once your fuel lowers, he gets much more responsive. And if you give it too much juice, he'll just shoot right into the ceiling because he's using acceleration, not velocity. So that's the entire game. And also, I would like to show you just the sprite sheets I used. So I have, this is the Lunar Lander sprite sheet I used. Mostly everything is here. There's my ship. I just cut this up. There's the hearts. There's the stationary ship. There's the kamikaze. This was one boss. This is the boss I used. These are the pickups. This is the fuel. These are the projectiles. These are the explosions that I didn't implement yet. Some backgrounds. But yeah, that's everything. Thank you for watching, Professor, and have a good winter break. Professor, I added sound. This is a last minute thing. I just wanted to add this onto the end. I have this sound manager class. Very simple. I literally just implemented a couple of these. I just added some of this stuff into the code. You'll see it. It's just, added it in. I just want to show you how it sounds. So when you play it, there's the soundtrack. You can shoot. When you shoot, you get a sound. When you pick something up, you get a sound. When the enemy shoots, you get a sound. There's the soundtrack. When you hit the enemy, just the boss, you get that sound. And then when you die, you get that sound. And that's the entire thing. Thank you very much.